Hi, good morning everyone. This is the third session of the third module, and in the first two sessions, we have seen how to find the solution of a second order linear ordinary differential equation with constant coefficients. In this session, we are going to see two different methods of finding particular integral of a linear differential equation. Okay, so one such method is method of variation of parameters, and this method of variation of parameters is to find the particular integral of a second order linear ordinary differential equation. Okay, so we have seen that this is the general form of a second order ODE, like d square plus a1d plus a naught of y is equal to x of x. This x of x is a function of x, and the solution contains two different parts, complementary function and particular integral. And when you solve the complementary function, or when you find the complementary function of this one, since this one is a second order equation, you will get two solutions, right? When you find the auxiliary equation, you will get two solutions. And when you write the complementary function, so this is what you will get. Some c1 times a function, we call that as y1 of x, and c2 times y2 of x, right? So this is a general form of a complementary function, and y1 and y2 definitely depends on the solution of the auxiliary equation. If they are real and distinct, this one would be some exponential functions, and if they are the same, one would be an exponential function, the other one x times an exponential function, and this one is if you get complex roots for the auxiliary equation, this one contains sine and cosine functions, right? Anyway, this is the general form of the complementary function of such a differential equation, c1 times y1 of x plus c2 times y2 of x. Now, to find the particular integral of this one, so by the method of variation of parameters, it says that the particular integral is like this: some u y1 plus v y2. y1 and y2 are obtained from the complementary function, and then u and v, these two functions have to be calculated, right? Where u is equal to negative integral y2 x over w dx, and v is integral y1 x over w dx, and w is determinant y1, y2, y1 dash and y2 dash, and this is called the Wronskian of two functions y1 and y2. Okay, so the method is really simple. We know what is the particular integral here. Directly we obtain using this formula. So it's enough to calculate these two quantities, u and v, these two functions. And where u is, this is a formula, minus y2 is here, we will get that. X is the right hand side of the function, and w is obtained by finding this determinant y1, y2, y1 dash, y2 dash, and this quantity, this one will not be zero, and the theoretical part of that we will see later. Okay, so this is the and integrate that. Then v is y1 is here, x is the right hand side of the function, and w is the Wronskian. So just to find u and v, and then you can calculate. Okay, so these are the formulas to be memorized. Okay, so directly you will get the particular integral, and that is the method of variation of parameters. And now we will see some problems. The first question is, solve d square plus 4 of y is equal to tan 2x. Tan 2x. See, if the right hand side is a function other than x e to the power x sin x cos x, then actually we didn't study a method for finding the particular integral, right? But using variation of parameters, we can do that. Whatever be the function on the right side, we can find the particular integral. Okay, and here it is tan 2x. So the method is simple. So first we are supposed to calculate the the complementary function. So first you write the auxiliary equation as this one is m square plus 4 is equal to 0. When you solve it, you will get m is equal to plus or minus 2i. Plus or minus 2i. Therefore, the complementary function yc is equal to, this is a complex roots, right? So we'll get c1 cos 2x plus c2 sin 2x. See, this is the general form. Like this one is like c1 y1 of x plus c2 y2 of x. So you can choose this one as y1 of x cos 2x and y2 is sin 2x. Okay, and directly you can write the yp. Therefore yp is going to be u y1 plus vy2, and now we are supposed to calculate this u and v. Okay, so we know the formula for u and v, but before that let's calculate the Wronskian now, because we need that in the formulas of u and v. So first calculate the Wronskian w. This is a formula y1 y2 y1 dash y2 dash. When you substitute, y1 is cos 2x, y2 is sin 2x, y1 dash derivative of cos 2x minus 2 sin 2x, derivative of sin 2x cos 2x. When you evaluate, this is like 2 cos square 2x minus minus plus 2 sin square 2x, and 2 is a common term. When you take that out, you will get cos square 2x plus sin square 2x. That becomes 1. So the answer is 2. And this is what the Wronskian is. Okay, so w, we obtain w. Now we are going to calculate u and v. So I'll erase this. So u is equal to, this is a formula, negative integral y2 x over w dx. That is negative integral y2. Here y2 is sin 2x. X is the function on the right side, that is tan 2x over w. W is 2 dx. Okay, and we are supposed to integrate this. Now it's an integration process. So integral of, we write tan 2x as sin 2x over cos 2x. This is going to be sin square 2x, and you can write sin square 2x as 1 minus cos square 2x over cos 2x. And now you can divide each term by cos 2x. So it's integral 1 over cos 2x is sec 2x minus, and here 1 cos 2x will be cancelled. and you will get cos 2x dx. Okay, so the integral of this one will give you the answer. Okay, now it's enough to integrate this one. So integral of sec 2x is log sec 2x plus tan 2x by 2, and integral of cos 2x is sin 2x by 2. And this 2 comes out, so the final answer is minus 1 by 4 log sec 2x plus tan 2x minus sin 2x. Okay, so that is what u is. The same way we can find v also. V. And v is equal to, this is a formula, integral y1 x over w dx. That is integral. Here y1 is sin 2x, sorry, y1 is cos 2x, x is tan 2x, w is 2. When you simplify this one, you will get, tan 2x is sin by cos. So cos will be cancelled and you will get sin 2x over 2 dx. Integral of sin is negative cos 2x over 2. So the answer is negative 1 by 4 times cos 2x. Okay. Now we have u and v. Therefore, we can write the particular integral yp as uy1 plus vy2. U is that negative 1 by 4 log sec 2x plus tan 2x minus sin 2x times y1. y1 is cos 2x plus v. v is this minus 1 by 4 cos 2x times y2 sin 2x. Okay, this is the particular integral yp, and the final answer is definitely y is equal to yc plus yp, and I'm not going to write that. So the final answer is y is equal to yc plus yp. Okay, so that's it. And we'll see one more problem. Okay. Okay, this is the second problem. D square minus 2d plus 1 of y is equal to e to the power x times log x. And here the auxiliary equation is m square minus 2m plus 1 is equal to 0. When you solve this one, you will get two values 1 and 1. So this one is a repeated root. Therefore, the complementary function is c1 e to the power x plus c2 x e to the power x. Here again we have two functions, e to the power x and x e to the power x. We choose the first one as y1 and choose the second one as y2. Okay, then find the Wronskian of that. Wronskian formula is y1 y2 y1 dash y2 dash. So y1 is e to the power x, y2 is x e to the power x. Derivative of y1, derivative of e to the power x is e to the power x. Derivative of y2, so derivative of x e to the power x, apply the product rule here. So x times derivative of e to the power x plus e to the power x times derivative of x. So this is what you will get. Now evaluate this determinant. So when you multiply, you will get x times e to the power 2x plus e to the power 2x minus x e to the power 2x. These two times will be cancelled. The answer is e to the power 2x. Alright, so that is the Wronskian. Now you find u using this formula, integral negative integral y2 x over w dx, and y2 is x e to the power x, x is e to the power x log x, and w is e to the power 2x. And here e to the power 2x will be cancelled and you will get integral of x log x. So we are supposed to integrate this one. Choose log x as the first function this as the first function and this as the second function. Then apply the formula of integration by parts. So first function times integral of x is x square by 2 minus integral of derivative of log x is 1 by x times integral of x is x square by 2, and here x will be cancelled and integral of x is x square by 2. This is our u. Now the same way we can calculate v also. I'll erase this and I'll do that. Okay, and this is v. Integral of y1 x over w dx, and y1 is here e to the power x is e to the power x log x over w e to the power 2x. This e to the power 2x, e to the power x, times e to the power x, this will be cancelled and it remains only log x. So integral of log x, we know the formula for that, x log x minus x, right? So we obtained v also. Therefore, now we can calculate yp as u y1 plus v by 2. U is here, y1 is here, v we have obtained, and y2 is here. And substitute that. And the solution of this differential equation is yc plus yp. Yc also we got it, and yp is this. Okay. Substitute all those values and that is the answer. So that's all about variation of parameters. And so here actually it's enough to memorize certain formulas like what is w, what is u, and what is v, and what is yp. That's it. That's all about method of variation of parameters. Now let's move on to one more method to calculate the particular integral of a linear ordinary differential equation. Okay. Okay, and this is v. Integral of y1 x over w dx, and y1 is here e to the power x is e to the power x log x over w e to the power 2x. This e to the power 2x, e to the power x, times e to the power x, this will be cancelled and it remains only log x. So integral of log x, we know the formula for that, x log x minus x, right? So we obtained v also. Therefore, now we can calculate yp as u y1 plus v by 2. U is here, y1 is here, v we have obtained, and y2 is here. And substitute that. And the solution of this differential equation is yc plus yp. Yc also we got it, and yp is this. Okay. Substitute all those values and that is the answer. So that's all about variation of parameters. And so here actually it's enough to memorize certain formulas like what is w, what is u, and what is v, and what is yp. That's it. That's all about method of variation of parameters. Now let's move on to one more method to calculate the particular integral of a linear ordinary differential equation. Okay. Okay, so next one is the method of undetermined coefficients, and this is the standard form of the linear second order ODE. And here actually this one is a method to find the particular integral. Okay, so if the function x of x, that means the function on the right side, if the function on the right side, if that is a constant, what can be its particular integral? Okay, that is what we are going to see. So if this one is a constant, then the particular integral is again a constant a. Okay, and our aim is to calculate this a. This a has to be calculated. All right, and if x of x is another function like just x, a polynomial function with 1 degree x, then its particular integral is of this form, a1x plus a0. That means if this is x, you will get a linear expression. So here actually we are supposed to determine these two coefficients a0 and a1. All right, and if the right hand side is x squared, then we can write the particular integral as some a2x square plus a1x plus a0. So here we are supposed to calculate these, or we are supposed to determine the values of these three coefficients, a0, a1 and a2. And if it's e to the power ax, then its particular integral is of this form, some a1 times e to the power ax, and this a1 has to be determined. And if it is sin ax or cos ax, then its particular integral is of this form, some a1 sin ax plus a2 cos ax. Here again we have to determine these coefficients a1 and a2. Okay, so that is what it means, like undetermined coefficients. So we know the general form of a particular integral if the function on the right side is of this forms. Okay, so in this general form we have to determine these coefficients. Okay, now these things has to be there in your memory. And one more thing, if it is x squared, this is going to be the particular integral, right? So in other way we can say that if it's like this one, like some x squared plus x minus 1, okay, then again you can use the same formula. All right, that means a second degree polynomial, if the right hand side is a second degree polynomial, then this is going to be the particular integral. Okay, this is not just for x squared, but any polynomial is of second degree, this is going to be the particular integral. And any linear equation of first degree, this is going to be the particular integral. Okay, now let's see some problems. Okay, this is the first question. Solve d square plus 2d plus 4 of y is equal to 2x square plus 3e to the power negative x. Right? So first you find the complementary function of this. So the auxiliary equation is m square plus 2m plus 4 is equal to 0, and you solve it. M is equal to, and here I think you will get complex roots, right? Okay, let's see. M is equal to minus b plus or minus root of b square, 4 minus 4ac, 16 over 2. So I'll get minus 2 plus or minus, this is 12. That means you will get 3. 12 is 3 times 4, so 2 square root of 3 I over 2, or minus 1 plus or minus root 3 I. This is what you will get. Okay, so the complementary function yc is going to be e to the power negative x times c1 cos square root of 3x plus c2 sine square root of 3x. Okay. Okay, so this is a complementary function. Right, so I'm going to erase this and let's see what is a particular integral. And for the particular integral, let the particular integral be, this one is a second degree equation. Therefore, its corresponding particular integral is of this form, a2x squared plus a1x plus a0 plus, and the particular integral of this one, let that be some constant other than these three. Okay, so let's denote that as some b naught e to the power minus x. Okay, some b naught e to the power minus x. Now we are supposed to calculate these four coefficients. Okay, so we have to calculate these constants, a naught, a1, a2 and b naught. So for that, actually this one is a particular integral, no? This one is a solution of this differential equation. So what it means that you find the first derivative and the second derivative of this one and substitute in this equation, then that must be satisfied. Okay, so you find, see, actually we need the second derivative of y and the first derivative of that and y and substitute it. So you calculate the first derivative yp dash, you'll get 2a2x plus a1 plus minus b naught e to the power minus x, and we need the second derivative also, and derivative of this is 2a2 plus b naught e to the power negative x. Okay, we call this as equation 1 and substitute these three in 1. Okay, substitute these three in 1, you'll get d square of y, that is this 2a2 plus b naught e to the power minus x plus then 2 times derivative of y. Derivative of y is y dash. So 2 times this one 2a2x plus a1 minus b naught e to the power minus x plus 4 times y. Y is this plus 4 times a2x squared plus a1x plus a naught plus b naught e to the power minus x, and on the right side we have 2x squared plus 3 e to the power negative x. Okay, so we have written the general form of the particular integral. We obtained its first and second derivative and substituted all these three in this differential equation. Now next, what we are going to do is, here we can see that there are some constants, there are some times of x, there are some times of x squared, and there are certain times of e to the power minus x. Okay, so you group them accordingly. First collect all the constants. So 2a2 is a constant, right? Next constant is, this is not a constant, it's a coefficient of x, and 2a1 is a constant. This is not a constant, this is not, but here we have 4a naught. So these are the constants plus. Now collect all the times of x. Here we have one 4a2x. This is not, this here we have one plus 4a1. So I'm going to write like this. Okay, so we have 4a2 plus 4a1 x, that's a time of x, plus now times of x square we have, there is only one time of x square, and that is 4a2x square. It's equal to, on the right side we have 2x square plus, oh, one more time is there, I forgot, that is the times of e to the power minus x. That is, we have b naught here minus 2b naught, and there is one time plus 4b naught times e to the power minus x is equal to e to the power. Okay, this is what you will get. So collect all the constant times of x, then times of x square, then e to the power minus x. Okay, and on the right side we have 2x square plus 3 e to the power negative x. Now what we do is just equate the coefficients of the corresponding times. Okay, on the right side we have only two times, right? Times of x square and time of e to the power minus x, and there is no time of no constant term on the right side, no term of x on the right side. Okay, so now equate the coefficients. Equate the coefficients. So here on the left side we have 2a2 plus 2a1 plus 4a0 is equal to 0, because on the right side there is no constant. Now term of x again, 4a2 plus 4a1, term of x on the right side there is no term of x, so that will be 0. And term of x square, 4a2 is the coefficient of x square, and on the right side we have a term of x square, its coefficient is 2, so that will be the same. Then coefficients of e to the power minus x, b0, and you can simplify this one, right? 4b0 minus 2b0, I mean 4 plus 1 5, 5b0 minus 2b0 is 3b0, is equal to coefficient of e to the power x is 3 here. Okay, so these are the 4 equations we will get. So from these equations you can solve all these constants, solve for all these constants. Okay, for example, from the last equation you will get, b0 is equal to 1, right? And a2 is going to be, and from here you will get a2 is equal to 1 by 2, right? And if a2 is 1 by 2, you know, here actually 4 times a1 plus a2 is equal to 0. a1 plus a2 equal to 0, where a2 is equal to 1 by 2. So from that you will get a1 is equal to minus 1 by 2, because sum of a1 and a2 should be 0. Okay, so it remains only, so we got all the there were 4 constants. Out of 4 we got b0, a1 and a2. Now it remains only a0. So a0 is equal to, you can divide the whole equation by 2, you will get 2 a0 is equal to minus of a1 plus a2, and a1 plus a2 is equal to 0, therefore a0 is equal to 0. So these are the values, right? So we got all the constants, therefore we can write directly yp. Therefore yp is equal to a2 x square plus a1 x plus a0 plus b0 e to the power minus x, right? And substitute that. So a2 is 1 by 2 x square, a1 is minus 1 by 2x, a0 is 0 and b0 is just 1. So this is the particular integral. Alright, and the final solution is yc plus yp. Alright, so that is the method to find the particular integral using method of undetermined coefficients. Okay, hope you understand, right? Okay, so we'll do one more problem like this. Okay, so this is the second problem. It seems to be a simple one. D square plus 1 of y is equal to sin x. So first, as I told you, see, first we write the auxiliary equation, m square plus 1 is equal to 0, solve for m plus or minus I, and we write the complementary function c1 cos x plus c2 sin x. Okay, now the particular integral, since the right hand side is sin x, we write the particular integral as, you know, c1, I mean not c1, but we use some other constants, some a2 a1 cos x plus a naught sin x, right? Okay, and here note one thing, that our complementary function has sin x and cos x, and that same sin x is there on the right side. Okay, or when you write the yp again, these two has the same these two has or these two are almost the same type of functions, right? Because a linear combination of sin x cos x, here again we have a linear combination of sin x and cos x, so that won't help you to get the particular integral. Okay, so simply saying, when you write the complementary function, if any of these functions are there on the right side, okay, then when you write its particular integral, you add one more x here. Okay, that is just some a1 x cos x plus some a2 x sin x. Okay, it's because this sin x is there in the complementary function, therefore we have to put an x before that. Okay, that's the only difference. So when you write the general form of the particular integral, this thing has to be there in your mind. Okay, now the methods are the same. You find, actually here we need only the second derivative, so yp dash is equal to or I write this as some x times a1 cos x plus a2 sin x. So x times its derivative minus a1 sin x plus a2 cos x plus a1 cos x plus a2 sin x times derivative of x. Okay, the second derivative is, here we have to apply the product rule, x times minus a1 cos x minus a2 sin x plus minus a1 sin x plus a2 cos x, that's the product rule of this one, plus the derivative of this, that is minus a1 sin x plus a2 cos x, right? Okay, so when you simplify this one, you get x times minus a1 cos x minus a2 sin x, and this is 2 times sin x plus 2a2 cos x. This is what the second derivative, and substitute this one in the actual equation. Okay, so second derivative of y is this, so x times minus a1 cos x minus a2 sin x minus 2a2 sin x plus 2a2 cos x plus then y. Y is this, x times a1 cos x plus a2 sin x is equal to sin x. Okay, so and now the simplification is easy, because here we have minus x a1 cos x, here we have plus a1 x cos x, and minus a2 x sin x plus a2 x sin x. So these terms will be cancelled. Okay, these times will be cancelled, and you will get minus 2a2 sin x plus 2 this is like 2a1, right? 2a1 sin x, 2a2 sin x. Okay, so 2a1 sin x plus 2a2 cos x is equal to sin x. Now equate the coefficients. When you equate the coefficient, you will get minus 2a1 is equal to 1 and 2a2 equal to 0. That means a1 is equal to minus 1 by 2 and a2 is equal to 0. And we obtain the constants a1 and a2. Therefore, the particular integral is yp is equal to x times a1 minus 1 by 2 minus 1 by 2 cos x, and a2 is 0. So that's it. Minus 1 by 2 x cos x. Okay, and the final solution is y is equal to yc plus yp. Okay, so that is all about the method of undetermined coefficients. Now we have done only 2 problems, and I will give you some tutorial questions. You try that. Okay, so that's it.